We're going to go through all of the questions that you guys practiced in class today, and I want you to write down any questions. If I do anything that you don't understand, I want you to write that down too and bring it to me tomorrow. Okay, question 1 is about graphing in standard form. So we're going to start with the formula negative b over 2a. So I have negative 1. It's my x value. I'm going to plug that in, and I'll get negative 1 squared plus 2 times negative 1 minus 1. So that will be positive 1 minus 2 minus 1, which is negative 2. So my vertex is going to be the point negative 1, negative 2. That means the axis of symmetry down here will be x equals negative 1. So now let's plug in 0. When I plug in 0, I'll get out negative 1. So we're looking at some sort of a graph like this. You really need to have this graph before you start answering everything else. This one then is going to be a minimum. It'll be a minimum at negative 2. The y-intercept just basically means where it crosses the y-axis. So we could call it the point 0, negative 1. You could also say at y equals negative 1. The domain is all real numbers. The range will be from negative 2 to infinity. Increasing is going to be from negative 1 to infinity, because it's going to start here at negative 1 and then increase from negative 1 as the numbers get larger, the y values get larger. It's going to decrease from negative infinity to negative 1. Okay, question 2 is going to be in vertex form. So the vertex part of this will be easy. It will be negative 3, negative 1, with an axis of symmetry of x equals negative 3. So let's start there, negative 3, negative 1. We need to pick a point, so let's pick, I guess, negative 2. So f of negative 2 would be, let's see, so negative 2 times 1 squared minus 1 would be negative 2 minus 1, which is negative 3. So negative 1, negative 3. Oh no, I'm sorry, I plugged in negative 2. Let me try that again. Negative 2, negative 3. That means it's the same on the other side. So now I have this downward facing parabola, which makes sense because the question has a negative in the front, meaning it flips over the x-axis. So now I'm going to have a maximum, and that maximum value is going to be at negative 1, which is the y value of the vertex. My y-intercept in this case, and I know we didn't cover this in class, but any point on the on the y-axis is going to have an x value of 0. So all of these points are 0 and then some number, like 0, negative 1, 0, negative 2, 0, negative 3, 0 and some number. So what that means then is I'm just going to plug in 0 for x, and that's going to give me my y-intercept. So I'm basically solving this. So I would have negative 2 times 3 squared minus 9. Remember, order of operations says we need to multiply 3 squared first, so that would be negative 2 times 9. Minus 1 would be negative 18 minus 1. The y-intercept would be the point 0, negative 19. Sorry about that. The domain will be all real numbers. The range will be from negative infinity to negative 1. it will be increasing from negative infinity to the x value of the vertex, which will be -3. And then it's decreasing, picking up at -3 onto positive infinity. Check your work. I hope you did this right in class. Okay, now for the new stuff. The different types of word problems. The nice thing is that you're always going to be given the function. Okay, so that's, you know, don't get confused by all the words. All it really is doing is describing what this means. So we know that x is going to be the horizontal distance in feet, and y is going to be the height in feet. All right, so let's talk about part A. It says how high, so that's going to be my y, like I just read out. How high can a gray kangaroo jump? So we're going to take this function, and since it's in standard form, we're going to start with finding, we want to know how high it is. Then that means if we have this, let's see, we could do something like this. We know it's going to be a downward facing parabola. So we're going to think of something like this. Okay, so we got our little kangaroo. I don't even know how to draw a kangaroo. Or a kangaroo here, and it's going to be jumping. And we basically want to know how high it's going to jump. It's going to reach its maximum jump. So that's going to be the y value. The horizontal distance would be your x value. Okay, so in order to find that, we really just need to find the vertex. So we're going to start with negative b in this case. We got some crazy decimals here. That would be -0.8 over 2 times the a value. Let's see. And I'll use my calculator here. Okay, I'm getting 14.98, and again, it does say round to the nearest foot. So let's just use 15, just to make it, I mean, it's so close, we're just going to make it use 15 for that. Now that is not my answer though. My answer is asking how high. This is going to be the horizontal distance, so this would be the x value that we found. We want to find the y value, which says exactly how high this kangaroo is jumping. So all that means we need to do is we need to take the function at the x value. So that will be will look something like this. Okay, again, I'm going to use the correct order of operations with my calculator. After we use order of operations, we're going to get, I have 5.99 feet, so we're just going to call that 6 feet. Okay, so the height will be 6 feet. All right, now for part B, at what distance is the kangaroo at its highest? So we actually already found that, because the distance that it's at its highest would be the x value here. So since we already found that answer to be 15 feet, that's the x part of the vertex. And then the full distance that the kangaroo jumps, that means from beginning to end. So if we know that here to here is 15 feet, we know that with axis of symmetry, there's got to be another, from the vertex here, there's got to be another 15 feet. So we're going to say that that should be a full 30 feet. So all we're really doing is doubling the distance to the vertex. Okay, another question similar to that. So if we were to think about a picture, I have a soccer ball. This is going to be negative again. So we're looking at a couple different situations here. The height of the ball increases until it reaches a maximum height of 8 yards and 20 yards away from the player. So what that is though is the first kick. So this is, we can call that the first kick, because what we're trying to do, if you have read the question already, is we're trying to compare it to the second kick. So a second kick is modeled by this function here, which we're going to have to play with a little bit in order to answer the question. It's not really in any form that we can solve, so we're just going to put it in that form. And then we're going to ask a series of questions about it. Okay, so let's start by putting this thing in the right form, and all we're going to do is distribute the x. So this would be 0.4x minus 0.008x squared. Okay. And I also want to put it in A, B, C form. So it'll be negative 0.008x squared plus 0.4x, and then there's no C. All right, so let's see what it is we actually want to find. Which kick travels farther before hitting the ground? So travels farther before hitting the ground is going to be the total distance from 0 to where it hits the ground. So this is at 0 seconds, this is at however many seconds, we're not really sure. So we really want to find this distance and then compare it to the first one. Okay. So we're going to start again by finding the vertex. So we're going to do x equals negative b over 2 times a. Okay, and I got a clean 25 out of there. Okay, so we're looking at 25 yards. And again, that's just going to be halfway through. So that's where the vertex is. So that's 25 yards. So the full distance before it hits the ground again is going to be another 25 yards. So we're looking at, for the second kick, we're looking at a total of 50 yards. Okay, now let's compare that to the first kick. The first kick said it's going to go, the ball increases, it reaches its maximum height of 8 yards, 20 yards away from the player. Meaning, in the first kick, if it's 20 yards away from the player before it reaches its maximum height, then this is going to be another 20, which would make that a total of 40 yards. So we want to know which one kicks farther. That's going to be our second one. Okay, so the answer to the first question would be the second one is going to travel farther. Okay, the next question is which kick travels higher? All right, so in order to answer that one, we already know that the first one is 8 yards high, so we need to kind of compare that to the second one. So we're going to take our 25 that we found for the x value, and we're going to plug that into the function. So that would look like 0.4 times 25 minus 0.008 times 25 squared using correct order of operation, and that comes out to 5 yards. Okay, so the height of this, the second one here, the second kick is going to be 5 yards, but we read that the height of the first one was 8 yards. So the one that's going to have the higher kick is going to be the second. No, I'm sorry, it's going to be the first one in this case. Okay, so that's the answer to question 2. And the last one, the one that I added in by hand, says what is the total distance of the second kick? So actually we already found that. The total distance is going to be 50 yards for the second kick, because it was 25 to the vertex and then another 25 on the opposite side. Okay, here's another situation where we have an impala that's jumping. So again, we have that negative facing down parabola, which should make sense in this case. Let's see, we have x is the horizontal distance. So this is your x, and then your y is, y is the height. Okay, what we want to know is how high can the impala jump? So to get that height there, which would actually be your y value of the vertex, we would need to start with the x value of the vertex because we're in standard form. So we're going to take negative 1.3333, which is now our negative b, over 2 times a. And I got 15.01, which we're going to call 15 feet. Okay, again, that doesn't answer the question. I want to know how high. So now I have to take f of 15, and let's plug that into the function. Okay, correct order of operations would be exponents first, And we can go ahead and multiply that. And I have 19.9995. And after multiplying and then adding, I get an answer of about 10 feet. Okay, so the answer to the question, how high can the impala jump? It can jump 10 feet, and that is after it's 15 feet away from where it started. Okay, so the answer to this is 10 feet. How far can the impala jump? Has to be this landing spot over here. So if it went 15 feet before it got to 10 feet in the air, then it's got to go another 15 feet to land. So in that case, it would be a total of 30 feet. Okay, and then the last question just has you read a graph that's already there. So here's a time versus position graph. How many seconds total is the football in the air? So your time is going to be here, and your position will be here. So the seconds that it's in the air is going to be 6 seconds total. Okay, so that's going to go from beginning to end. That's the time frame that it's in the air. The maximum height of the ball is going to be here at the vertex, but that height is going to be at 9. And they're not giving me units, so it could, oh yeah, they are, I'm sorry, it's in feet. And t is in seconds, so we're going to make that 6 seconds. What interval is the football increasing? So we're going to be increasing from 0, and we're going to increase all the way until we get to 3. From 0 to 3, we're increasing. So for decreasing is going to be picking up at 3 and going until we get to 6. So from 3 to 6. How many seconds pass until the ball reaches its maximum height? So the maximum height, again, is at this vertex. So the amount of seconds that pass would be 3 seconds. Okay, bring any questions that you have for me tomorrow, please.